This code provides a basic implementation of a stack data structure using a linked list approach. It allows you to push, pop, pick at the top element, and check if the stack is empty. Let's break down the provided C# code step by step. The code defines a namespace stacks. Inside the namespace, there's a generic class stack T, where T represents the type of elements that will be stored in the stack. Within the stack T class, there's an inner class called stack node T. Each stack node T instance contains a data field of type T and a next field that points to the next node in the stack. The constructor initializes the data field with the provided value. The stack T class contains two fields, public field count and private field top. Count is an integer that keeps track of the number of elements in the stack. Top is a reference to the top node at the stack. Pop method. Pop removes and returns the top element of the stack. It first checks if the stack is empty. If it is, it throws an exception. It then receives the data from the top node, moves the top reference to the next node, and returns the data. Push method. Push T item adds a new element to the top of the stack. It creates a new stack node T with the provided item. It sets the next field of the new node to point to the current top of the stack. It updates the top reference to point to the new node. It increments the count field to reflect the addition of a new element. Pick method. Pick returns the top element of the stack without removing it. It checks if the stack is empty and throws an exception if it is. It returns the data from the top node. IsEmpty method. IsEmpty checks if the stack is empty by checking if the top reference is null. It returns a Boolean value indicating whether the stack is empty or not.